In this video, I will go over set operations, but I will mainly solve the problems. So make sure you read the definitions, read this text that it's written here carefully, and just really quickly, when we see this U, the operation is union, and it also it's attached to the word or this symbol, and what it means, we put all together, right? So here are union, the symbol, the word, what happens, we put all together, or the symbol from logic. Intersection, it's this symbol, upside down U, the word on, and the operation or what we are doing, we are looking for common values and the symbol of and. Complement, it's denoted by a bar, and it means not in A. The difference, A minus B, means in A and not in B. So please read this, how it's denoted using a set notation for the union, how the intersection is denoted, how the difference is denoted, and how the complement. So now let's go to the examples and let's solve a few of them. So for example, we have the set U, which is the universal set, and in this case it contains the values 0, 1, 2, 3, 4, 5, 6, 7. And then we have the set A that contains 1, 2, 3, 4, 5. And then we have the set B, 0, 3, 6. And then we have C, 0, 7. And we have to calculate all kinds. So solution, and I am going to do A union B means I'm going to read A and B, and I'm going to put everything together and written once. So 0, 1, 2, 3, 4, 5, and 6. So some of them are in A, some are in B, some are in both. B says A intersection B, and the intersection was common. So I'm looking again at A and B, and I'm trying to find what numbers are in both sets, and that is 3. C is A minus B, which means elements that are in A and not in B. So basically 1 is in A and is not in B, 2 is in A and is not in B, 3 is in B, 4 is in A and is not in B, and 5 also is in A and not in B. So we did A minus B, and I need this, right? So I'm going to keep it like that. Then we have D, which is B minus A. Well, B minus A means what's in B and not in A. So 0 and 6, because 3 is in both of them, which we had here. E has A intersection C. So now we look at common between A and C. So if we look at any elements, there is nothing in common between A and C, so we could write it like this, or we could use the empty set notation. F is the complement of A, or not in A, right? So not in A. But where? Right? So what does it mean not in A? Well, it means I will have to compare A with the universal set. So I'm going to look at A and U, so not in A, but in the universal set. So to find the complement of a set, I need to have this U, universal set. Without it, I cannot find the complement. So 1, it's in U and in A. 2, it's in both. 3, it's in both. 4, it's in both. 5, it's in both. So what is not in A from the set U? 0, 6, and 7. So ones that we did not cross out. G is B bar, so the complement of B, not in B, but in U, right? So I do need to compare now U and B. So 0 is in B, 3 is in B, 6 is in B. So what is left? And what is not in B but it's in U, it's 1, 2, 4, 5, and 7. Just crossing them out helps. age is A bar union B bar. So in order for us to actually make this operation with sets, we do need to have A bar first and B bar. So we do have them above, but if we didn't have, you should have calculated A bar separately and then calculate B bar separately and then do the union. So since we have them, then the union is going to be all together written once. So 0, 1, 2, 4, 5, 6, and 7. You see 7, it's in both. I copied only once. And A bar intersected with B bar. So if we look for the common one, we notice it's 7. But again, we did have A bar and B bar calculated previously. If we don't, we have to calculate them separately and then find whatever operation we need. And we have all kinds of other problems that we can do in this case. So we can also have, for example, J, A union B intersected with C, for example, or K, A bar intersected with B bar union C. You know, we can have all kinds of problems. So I want you to do this on your own and bring them to me to class.